Hello everybody, thank you for watching. This is our 9.5 video on the effects of pressure. In this video, we're going to review the kinetic molecular theory and talk about different interpretations of different effects of gas pressure using our kinetic molecular theory. So let's quickly review the three basic assumptions of the kinetic molecular theory. We know a gas is composed of particles that are considered to be hard spheres and are relatively far apart from each other, having some empty space between them. We also know that these particles are in constant rapid motion, usually traveling in straight lines, independent of one another. And the third assumption is when these collisions or these particles are going to collide with one another, the collisions are perfectly elastic. That means that as they collide, there's no loss of energy and the average kinetic energy remains the same. So in general, if you take a look at this image right here, this quickly explains the kinetic molecular theory. Using the kinetic molecular theory and those three basic assumptions, we can predict effects of gas pressure. So we're going to talk about some causes and then talk about their effects. So let's say we have a box of different particles of gases and we're adding heat to this particular given area. What's going to happen as an effect is the molecules within the container are going to move faster because heat is being applied. Therefore, the number of collisions to the walls of the container are going to increase. And if you remember, the more collisions on the walls of the container, the pressure has to increase, the more the pressure. What happens now if we remove heat from the gas? All right, so we're lowering the temperature now. The particles are already kind of heated up from the first part. But if we lower the heat, the particles now are moving slower. Because they're moving slower, the collisions against the walls of the container are going to decrease. Because we have less collisions, we're going to have a lower pressure. So the key idea I want you to remember is the more collisions of gas molecules within the walls of the container, the higher the pressure. The less collisions against the walls, the lower the pressure. Let's talk about some more different effects on gas pressure. What happens now if we take this container and we increase the volume? So what's going to happen is these particles, since they're moving independent from each other, they're still going to move at the same speed. But what's going to happen is because the container is bigger, you have a bigger space, there's going to be less collisions within the container. And because we have less collisions, therefore the pressure will also decrease. What if we take the container and decrease it and make it a super small container? The volume is going to decrease. The particles within the box is still going to move at the same speed, but you're going to have an increased amount of collisions. Because you have more collisions, your pressure is going to increase within the container. The last effect we're going to talk about is the increased amount of gas. So what happens now if we take this container and we add more molecules inside of them? Your molecules that you're adding are the same molecules that are already in the container, so therefore they're still going to be moving at the same speed. But because you have more molecules now, you have an increased number of collisions. So therefore, again, the pressure will increase. And I like to give the analogy of if you're driving on the highway, there's obviously more cars there compared to if you're driving on the countryside. So you have a higher risk of getting into an accident on the highway than you do on the countryside. So the more molecules, the more number of cars, therefore your pressure is going to increase. And that concludes our video for today. Thank you for watching.